Hey everybody, I hope you're doing well and having a nice day. My name's Zaki and I am a materials research scientist and graphic designer from France. If you follow me, then maybe you've came across one of my recent posts announcing this additive manufacturing video series project. And the core idea here is to share with you some knowledge, trends and facts and random stuff about additive manufacturing, or what is commonly known as 3D printing. So now, without further ado, let's get started with today's topic, additive manufacturing industry, key numbers. The first key number that we are going to cover is the number of additive manufacturing companies and institutions. This number rises to over 231, according to the most recent report by the AMFG, a leading provider of automation software for industrial 3D printing. And of course, there are numerous new players that continue to enter the additive manufacturing market, while partnerships and acquisitions, they continue to develop across the industry. So now, if you're wondering whether this number is underestimated, the answer is yes, because this number only concerns companies that provide solutions for industrial applications. With that being said, companies that primarily have a consumer 3D printing focus, or those who provide 3D printing services, are not included. Always according to the AMFG report, among these 231 organizations, the hardware companies make up over 50% of the entire landscape. In the second place, the 3D printing materials market occupies around 20% of the industrial landscape. The third component is the software vendors, then followed by post-processing manufacturers and research institutions. Now, when we focus on these hardware companies or manufacturers, what we find is that the metal 3D printing represents the largest segment with almost 40% of the landscape, then followed by the manufacturers of polymer machines, desktop 3D printers, composite machines, ceramic 3D printers, and finally the electronics machines. By the end of last year, 2019, Smartech estimated the global additive manufacturing market to be worth over 10 billion US dollars. This means that the additive manufacturing industry is crossing the double-digit billion thresholds for the first time in its almost 4 decades history, and seeing a year-over-year growth of 25% since 2014. According to the 2019 Global EY report, Europe is the region with the most additive manufacturing firms, representing about 55% at a global level. In the second place, America with 32%, and then Asia in the third place with 13%. Now, at a country level, the US has the highest number with about 29% of all companies combined, while Germany is second with 24%. As the COVID-19 pandemic spread rapidly worldwide, PPEs, or personal protective equipment, are in great shortage with increasing demand. This is especially the case of isolated communities. If the COVID-19 pandemic has taught us anything, really, it's that supply chains can be disrupted subtly and with no indication of how long this is going to last. And this is exactly where additive manufacturing plays a major role, thanks to its on-demand and local production features, thus providing more PPEs without relying on the conventional supply distribution chain. Given the additive nature of additive manufacturing, or AM, we might think that from a sustainability perspective, AM makes a 100% resource-efficient manufacturing process. Why? Because less waste is generated compared to other subtractive techniques. Now, this is only partially true, and just because it's additive, it doesn't mean that there is zero material waste. You could think of support plates, support structures, overhangs, post-processing, thus involving machining, and all of these produce some waste. This sustainability discussion is a very complex one because it requires a much wider boundaries of research and investigation rather than a well-constructed scenario of additive versus subtractive manufacturing process. And it really depends on what material, part geometry, and process are we talking about. Now, if we pick metal additive manufacturing, there is one interesting study conducted by Digital Alloys that I'd like to share with you. Now, what Digital Alloys did was actually comparing the energy consumption of different metal additive manufacturing technologies with CNC machining of a titanium aerospace part. This part, as you can see, is a bracket used in the fuselage of commercial aircrafts, and it is currently being manufactured by CNC machining. It is worth mentioning that this part has a 17:1 buy-to-fly ratio, which means that you would need a 17 kilogram workpiece or billet to manufacture your final part, weighing only 1 kilogram. What is really interesting is that this study has revealed that you're likely going to consume 5 times more energy by machining this 1 kilogram part rather than additively manufacture it by laser powder bed fusion, for example. And the reason behind this disparity can be explained by the large amounts of material waste generated by rough machining. And finally, to close this very first video from the Additive Manufactur𝗶 video series project, I'd like to read this beautiful quote from Wilfried van Kraan, co-founder and CEO of Materialise. Additive manufacturing empowers people locally through decentralized production. It improves people's health and well-being through personalized care and enables high-quality jobs. Additive manufacturing also supports a manufacturing process with less waste through mass customization and optimized distribution. While additive manufacturing is a positive force that helps companies to operate more sustainably, that's not enough. The additive manufacturing industry itself needs to step up too by developing new and innovative ways to reduce its impact. And that will be the challenge not only for 2020, but also for the years to come. Thank you for watching.